Excellent. Very exciting.
Brilliant. So, Chris, we are live. Welcome to BioFutures in Conversation. For this set of three, a trilogy for World Futures Day. And I thought, you'd be an ideal person to bring into this because you are, I think it's fair to say, working at the cutting edge of material science. So I wanted to kick off. Some of the people that tune in are going to know your work, but others won't. And I wanted to be able to give folks a little bit of a background. So tell us a little bit about where you started out before you got involved in biomaterials.
Yeah. If helpful, I can bring some pictures in to try and sort of bring this to life.
Yeah.
Just kind of helps everyone see, maybe a little bit kind of what it was like. So hopefully those show up. Okay.
I can see them. They are streaming.
Great. So I started out my career as an engineer. I grew up in the countryside in the UK, and my first jobs after I studied engineering at Cambridge were really about this kind of technical optimization of things. So my first project here was the design of the Jaguar Land Rover, Jaguar's first electric vehicle, the Jaguar I-Pace, and it was a really fascinating project because it was the pinnacle of reductionism, but also the pinnacle of sustainability. And we were a team of a few hundred engineers locked in an off-site location with no influence of the outside world, so we could be as forward-thinking and radical as possible. And after many years' work, we actually ended up with a vehicle that would had roughly the same environmental impact as a normal diesel engine car at the time. And I also worked on sustainable footwear. So I was working in the US, and we created sustainable recyclable footwear. And the idea was that at the end of life, someone could return it to us, and it could be reprocessed and turned into a new piece of footwear from the materials we were using. But again, after all of that work, there was actually zero of our customers ever actually returned the product and recycled it.
Oh.
And so for me, there were these kind of very common themes coming up, but partly they were related to the materiality. The materials were only marginally better. The other thing was related to the human behavior. So with the electric vehicles, they had to, they're really fun to drive. And actually, a lot of people don't know this, but the tire wear on an electric vehicle is about double that of a normal car. And actually, where I live here in France, in Annecy, there's actually just been a pollution report that's found that there's a huge amount of tire particulate pollution in the lake, which was previously thought to be kind of wonderfully glacially pure water. And I'm certain that the increased tire wear from electric vehicles may have something to do with that. And so it kind of came down to this thought experiment of, could we as humans design anything as beautiful or as elegant as a tree? And, for me, the conclusion was, well, absolutely not. We just, no way can we ever play with this kind of a materiality which is as elegant or ingenious as nature. If we tried to make a tree, it would be full of pumps and wires and solar panels and all sorts of stuff. And the other thing that kept coming up with my work was that this here on the screen is actually the first ever plastic. It was called celluloid, and it was invented in the 1800s. And it was designed as a replacement for ivory. And this theme kept coming up through all of my work, where all the problems that we were facing today, when you really kind of look back at where they came from, they've all come from someone who was originally trying to do good. And here, celluloid was invented as a replacement for ivory, so that we could have, the beautiful looking cutlery that people wanted without having to, poach elephants. And I think, it's really important to remember that, what we're designing in the future has got these really significant consequences, even though we think we might be doing something good. So that's a little bit about my background and some of the things that I learned through my early career.
Brilliant. So you started off in a more, shall we say, conventional space, but you were thinking about the problems that the design community is facing in terms of materiality, in terms of waste, and not just with respect to the product itself, but tire wear and these. I guess you could say they are fundamentally a problem of the material which in Taiwan is the erosion that is caused principally by braking, which obviously with electric cars is double because they are heavier, and so the braking impact on the tires is more significant. So you start to think about it. And how did you first get involved with biomaterials? How did you get into that space?
Well, I grew up, in a, kind of in a rural agricultural environment, and everything we were doing was around, we were, working very closely with nature, um, which was lovely. And throughout my career, biomaterials always, appealed, but they were always, limited in terms of, how you could put them into the interior of a car, which is a very harsh environment, or actually, more often the question was, well, is this material any better? Um, and I think a lot of people overlooked as well that there's an awful lot of biomaterials that are already in use.
Yeah.
In a car, the leather seats that we use, leather is the most remarkable biomaterial. In clothing, in fashion, cotton is the most amazing biomaterial. The fact that we can grow a plant and weave it into durable, wonderful fabrics.
Yeah.
And obviously, then if you start getting really, really abstract, you actually well, plastics are derived from crude oil, and at what point, do they actually count as a plant-based material? So it's, I think I always found the definition biomaterials very challenging because actually, you can make a biomaterial in a very, very bad way, and a lot of people believe that biomaterials are the future, and I think if you look at some of the recent developments in mycelium leathers. Um, there are companies in the US who are now building very large factories, either in North or South Carolina. I can't remember which one, and they are building large industrial facilities to produce mycelial leathers at scale. And yes, that's great, but actually, what really matters is where are they getting their feedstocks from? How are they processing their materials? How are they processing their waste? And for me, when people think about biomaterials, it's easy to fall into the same old trap and say, okay, how can we make a biomaterial at scale industrially at a very affordable price? And actually, biomaterial, that's not how biology works. And I always make the analogy of bakeries. In France, where I'm living, there are more than 50,000 bakeries, and every day there's more than 28 million baguettes that are cooked across the
There is
country.
a law actually that says, isn't there, that over a certain number of people, a commune has to have a bakery.
Exactly. And And that is a much more, this distributed system where every single town and city is, producing its own very complex, like, look at a croissant is an absolute masterpiece of biotechnology. Uh,
Mm.
and so, that's happening in a distributed way. It's not, one giant bakery in the center of France that's trying to produce enough bread for an entire population, which if you, use the traditional rules of, economies of scale and so on is where you'd end up. And my degree at Cambridge was in manufacturing engineering. So I've been, I was trained in industrialization, in scaling up operations, in cost reductions, in quality and reliability. That's my bread and butter. And I think for me, that's very important as a foundation because I know what the state of the art is in manufacturing. And I think that allows me to understand its flaws and see, different ways of approaching manufacturing and creation of fabrication.
And as you said, I know that you grew up in one of the most rural areas of the United Kingdom.
Mm.
And so you were exposed to those processes. At what point did it occur to you, I can actually draw on some of the insights that I gained from that background working basically on the land, connecting and out there seeing the workings of nature?
Yeah, I mean, lots of moments of, working with natural materials growing up, but the one that always comes to me is the wool from our sheep. So we had a flock of sheep, and every year we would go and shear the sheep because, apart from a few specific breeds, sheep have been bred to have a very healthy fleece because not only then do you get the meat from the animal, but you also then get the wool from the animal as well. And that's something that we have bred into these animals as a way of being incredibly resource efficient. We've got something that's not only a walking food, it's also a walking clothes factory. And but every year we would shear our sheep, and the wool board, we'd take the wool to the wool board, and there's 50 or so fleeces, and we'd be offered 1 or 2 pence.
It's
And
shocking,
so
isn't it? It's
it
really shocking that
is this
it's so
amazing.
undervalued.
Yeah, and yet the economy and our environment and that material means that it was cheaper to burn it, and so many people do burn it. And I think for me that was heartbreaking to see this absolutely miraculous material um, being just burnt and disposed of. And that, I think, was definitely one of the moments where I really realized that it's not just about the materials. It's actually about the entire system we have built around it. It's around the system we
Yeah.
have of not only processing, manufacturing, design, and so on, but it's also around narrative. And the narrative around wool. Wool is this incredibly technical material, and yet it's the power of design is that you can tell that story, and you can create desirability, and you can add value to a material. And that is that's definitely one of the key moments, and one of the things that definitely has made me think a lot about what I'm doing today.
Brilliant. Now, I am a little bit jealous of your Lucid Life project because when I was looking at your Dropbox of images, there were pictures of you off on a tropical island. I think was it Tahiti? It's in
Yeah.
French Polynesia. In your shorts on the beach, sampling to get the bioluminescent marine organisms, and I thought that's a project that is definitely a great way to be researching something. How did you end up working on that? What's the story of that?
Yeah, so I left the industry. I was working at the French outdoor brand Salomon, and we were working on durable, recyclable outdoor equipment. And the company decided to move all of the production of the products I was working on from Europe to China, with 80% of the market for those products was in Europe. And also the company was committing to science-based targets, where they were planning to halve their emissions by 2030, but also they were planning to double the amount of kind of products that they were producing at the same time. And it was very clear for me that um, these weren't compatible in any way whatsoever. And so I left and decided to kind of commit to building a vision of the future that I thought was more viable. And I was at Central St Martin's, and I joined to do a kind of a research master's at Central St Martin's in London, which is this remarkable place where they've built a biology lab inside a radical art school. And so I went there, and I was thinking very deeply about what I wanted to do, and I got very stuck on this problem of defining life. One of the first questions we were asked was to define what is life, and I there was stumbled at the first point, but really at that point started to look at it. I discovered my favorite definition of life, which is from the physicist of cat in a box fame, Schrödinger, who said that life is anything which defies equilibrium. And
Yeah.
I love that definition. While it's technically not the most perfect or correct, I felt it was really captured the spirit of life being the only force which can reverse entropy. Life being the only force that can create beauty, order from disorder, or beauty from chaos. And I found it also very inspiring as a living thing myself to say, what is the structure that I want to go and build? What equilibrium do I want to go and push against? And so that really set me off on this route. But in my fascination around life, I got really interested in the actual state of livingness. I'd worked with many biomaterials before, and I knew that biomaterials, again, like I've said, they can be just as bad as any other material if they're not done in the right way. And for me, what I really got fascinated was living things. And I'd actually oddly had this long fascination with hedgerows. The British hedgerow is this remarkable piece of living engineering. They're hundreds of years old. They're essential for not only maintaining the wildlife, but providing these boundaries between our fields and providing a really important kind of function in our agriculture. And they're these entirely living structures that, there's millions of miles of them over our country that are all kind of maintained and cared for. And so, I really started looking at that. And then you look at beyond that to other countries, whether it's like the root bridges in Asia and the living kind of bridges that you see there. And for me, this state of livingness felt really fascinating. And that, nature's got these remarkable abilities. If we can collaborate with it, we can, have these, amazing materials. And so that got me fascinated with, living materials as a subject. But then I kind of was saying, well, what living materials can we work with? And I discovered this field called bioprospecting, where, companies,
Great term.
yeah, typically people will, typically a pharmaceutical company, let's say, often will go to remote locations in search of novel microorganisms. And the reason they do this is that because it's estimated for every one microorganism we know, there's around 100,000 that we don't know. And so that means that there's this huge biological unknown. And they refer to this as biological dark matter. And within this biological dark matter, it's believed that there will very likely be new drugs, new vaccines, new materials and chemicals that we haven't even dreamed of. And so there's a lot of excitement. And so people go out and they hunt for these microorganisms, see what they might be able to do. And then if they can capture them, then they're obviously going to be incredibly valuable. So I got fascinated by this and decided to research it. And I've just realized that, well, actually, do you want the true story of why I ended up in French Polynesia?
I want the true story, Chris.
Okay, true story.
I want the true story.
Okay, I'm going to share with you an image here. So it came from a thought experiment. And the thought experiment was this, that if you divided up the planet between the population of humans that live on it, so that each human would be a guardian, a custodian, or part of a unit ecosystem around one human, then if you divided it up, then essentially each human is associated with 2 football pitches of land and about 40-something swimming pools of ocean. And that's what this visualized here on this screen. And there's 2 things that kind of come from that. There's a lot more ocean than there is land. But it also, for me, was a really powerful mental model for looking at and understanding the resources we have around us and how that impacts us. And I was obsessed with this idea so much that I scanned the Earth for the perfect sized island for one human, exactly 2 football pitches big.
Okay. Love it.
And I found this. So this is an island out in French Polynesia. And so I decided to sail there. So we sailed there, and when we went to this island, and when we went there, it became very apparent very quickly that the most exciting thing here wasn't the land. As I mentioned before, it was the ocean.
Yeah.
There was so much going on in the ocean around this little island. And so then when I was out there, I then met people working in this field of bioprospecting, which is kind of this real hotspot out there in French Polynesia. And so this completely unrelated thought experiment then connected me to bioprospecting, and that's where the whole project emerged from, and that's why it happened in French Polynesia.
I love that idea. It reminds me of, back in the day when Darwin was off going to the Galapagos, of sailing around the world. And obviously in the past, we were going out to find out about nature in the sense of just trying to understand its fundamental workings, trying to understand evolution. But today, this new era of adventuring, in effect, and expeditions, but not to understand nature as such, but to understand how we can work with it, how we reconcile the gap between how we've been doing things and nature does things. So that's just a beautiful vision in my mind. I love the fact that you've gone out to this remote island, thousands of miles away, to find the inspiration. And how easy was it for you to actually find an organism that you thought, yeah, I can do something with this?
Well, yes. So actually what happened was I went out, I started taking samples. I had a few collaborators who were working in this bioprospecting industry. And I went out, I took a load of seaweed samples, and I followed all of, I had a government permit. It was also subscribed as part of the thing called the Nagoya Protocol, which is designed to make sure that if someone takes a microorganism, that is correctly attributed to the country that owns it, and should any value be derived from it, then the country from that organism has a right to its own biological intellectual property.
Right. Yeah.
Even though I was going through all of that correct protocol, I realized what I was doing was still an incredibly colonial activity. A white guy turned up on a random island, was going to take the microorganisms and try and find a use for them, while nominally, there being some financial benefit for, the country that came from them. And I realized that was this very colonial activity. And I felt, I reflect on how can we do this more responsibly? And so that was why I then returned to the island. And instead of looking at how can I use these microorganisms to create something, we then said, okay, how can we work with the local community to essentially bring these two worlds together of scientific research and indigenous knowledge? And it became around, how bioprospecting can work within an indigenous community. And that was, a fascinating process. When we were working with the indigenous community, there were an awful lot of really fascinating microorganisms. But generally, microorganisms, the most exciting thing they do is produce some kind of a slime. And while these slimes might have fascinating properties, and that many were, and the potential is enormous, when we were working with the local community, we said, well, actually, we need something that the local community find relevant and engaging and interesting and fascinating. And so we made the choice to work, instead of working with, a new and novel or unknown microorganism that I'd found, we made the choice to work with bioluminescent microalgae, which are, very well known. There's nothing new about them, but they are an microorganism that we could go out into the lagoon, we could capture the microorganism, and then we could cultivate it on the island. And that was, it meant that it felt much more understandable, comprehensible, inspiring, and that was a real key part of the project.
Yeah. And what I like about it, because I mean, when it comes to mythology, my strength is fire, because that's obviously my main area of research. But I look at those kind of organisms and I think there must be interesting mythologies around the bioluminescence. There must be indigenous narratives around that, because I can't imagine that peoples for thousands of years would have seen this extraordinary phenomena and not created some wonderful myth about it. But in a sense, what you're doing is you're creating a new story. You're creating a new story of our age, but actually in tandem working with the organism and with the people and joining up all of these dots, bringing in the near and bringing in the far. And then, of course, you've taken this project. I saw there's various iterations. There's the wonderful drum, the bioluminescent drum that obviously kinetically interactive, as it were. And then the beautiful collar as well. Just loved that. But obviously, one of your most, I guess you could say, well-known projects would be the dress that you produced in collaboration with Iris van Herpen. That I think it's fair to say viraled. It went global. How did that come about?
Yeah. So I guess just to touch on what you were saying about the kind of the connection with the knowledge. So when we kind of initially said, okay, we're going to make a living bioluminescent material and we're going to create objects from it, when I shared that with collaborators in Europe, their immediate response was, you're mad, you're a lunatic, it's completely impossible, you can't do that. When I shared that with the indigenous community in French Polynesia, they were completely open to the idea. They immediately would say, "Oh, that's amazing! It's you're in symbiosis. It's like you'll be a human coral. You're like connecting with a microalgae." They immediately understood this idea of symbiosis and connection to nature. And part of that is because they are a community that is much more connected to nature than maybe we are in Europe. But the other part of it as well is that they're inherently innovative. And actually, the reason that I believe that is in Polynesian culture you have the po and the au. This stands for the night and the day. And in Polynesian culture, they come from a history of voyaging, where they voyaged across across the oceans to French Polynesia, then on to Hawaii, traveling thousands of miles and navigating only by the stars. And when you're navigating by the stars, during the day you are completely lost, but it's at night when the stars come out that you find your direction. And so there's this very deep-rooted belief in Polynesian culture that it's actually in the unknown where you find your future. It's in the dark where you find where you're
Beautiful.
going. And
Love that.
so when I was presenting these very unknown ideas, people felt very comfortable with them. And Polynesian knowledge is constantly evolving. As with many indigenous kind of indigenous communities, most of the knowledge is oral. It's very rarely written down. And while to us, kind of Westerners, that can be very challenging to think that something could be lost. It's not been secured or archived or recorded. In what I realized was actually this is a much more beautiful way. And if anyone's seen the film Moana, in the film Moana, it tells the story of Maui and Tafiti. And Maui and Tafiti, the actual, the one of the key messages in this tale is actually that the best way to preserve something is to keep it alive. And that is, whether that is knowledge, tradition, or a material, the best way to preserve a living thing is to keep it living, to pass on that knowledge, to share that knowledge, to evolve that knowledge, to take the story that you were told by your grandparents and tell it in your own way. And so for me, it was that traditional knowledge that was so important. And then, yes, like where are we? Yeah. So the end result was we first made this swimsuit that you can see here in this image. And this was made with a local cultural educator, but also night diver and sculptor called Jeremy Tamari. And he had this idea of, I want a swimsuit that can illuminate underwater. So that when we're going night fishing and it's very, very dangerous, we can be kind of kept safe in the ocean as we kind of move and it illuminates.
And what was the idea that because it illuminates the marine creatures, for example, I know sharks sometimes hunt at night, would think it was so novel and unusual that they would keep a distance, or in what way would it create safety?
Well, with Jeremy, it was actually a tragic reason, and this was, not unique to Jeremy. It's quite common. But he'd lost 3 of his family members to night fishing. So
Ah,
at night, it's in the pitch black. They're diving to very, very deep depths. They're
yeah,
free diving, and he'd lost family members because they'd got trapped underwater, because they'd fallen unconscious when they're at a deep depth, and obviously it's
right,
total darkness, so you can't see the people that you're fishing with. You can't, they couldn't see them to go and rescue them. So his
yeah,
idea was this very, very functional one, was that if there's a safety problem underwater, I'll be able to see where
see,
my
I
sister
love
is,
that.
brother is, to go and find them. It was a very, very, actually came from a very practical but also tragic
From a
origin.
tragic source, but yeah, that makes a lot of sense because my diving, I'm not, fairly rudimentary in my diving skills, but I know that when the conditions are very bad, I'm pretty wary. I will not go out if I think it's very poor visibility. But the idea of a glow in the dark suit that you're like a bioluminescent creature, that actually that makes a lot of sense. I'd feel a lot safer if I was going diving at night in a bioluminescent outfit. Definitely. That's a very good, a very good potential application. And unfortunately, it is the case that sometimes it is a sad event. It's something that, catastrophic that happens. That is the catalyst for innovation. So how wonderful that, something that was a great tragedy has actually catalyzed this wonderful idea that potentially could be developed and applied to help save other lives.
Yeah, yeah, absolutely. And it was, while, for Jeremy, it had this very functional purpose. For me, obviously, I saw, well, we both saw this much, deeper meaning behind this around, the beauty of, being underwater and being surrounded by bioluminescence of this suit which responded to your movement and your touch. Um, Not only did it have a functional thing, it had a very, something that was, a very emotional reason behind it as well, around the movement, light, and connection to nature. And
Yeah.
it was the emotional side of it that caught the eye of Iris van Herpen, the Dutch fashion designer. And so, yes, together with Iris, she asked if, would it be possible to take this, this conceptual material and to make a full living dress for Paris Haute Couture Week in 2025. And I still look back at it and think, I don't know how we managed to make that possible. But within 3 months, we managed to go from producing small pieces of the material, and, being able to use them underwater, to being able to create this full living dress that contained 125 million algae, and was able to walk down the runway in Paris and illuminate and light up in response to the model's movements as she was doing that. Um,
It was magical. And
this
it,
You can see the dress coming off the mannequin, and so you can see how it works a little bit. Where in response to kind of movement and stimulation, like they do in the water, the bioluminescent algae start to illuminate.
yeah.
And again, this is totally experimental, and so really we're kind of very much learning as we went. And for example, this one here responded much better to stroking than to pressure. And it's actually a very complex fluid dynamics problem, and we had a lot of help from the University of Amsterdam. But that was yeah. And here's a video of it, kind of the final garment, kind of going down the runway, which was just a very spectacular moment.
And how many prototypes did you have to make before you got to the runway piece?
Um, Hundreds, absolutely hundreds. Essentially, Iris contacted me in February, and I was very kindly offered a residency at the University of Amsterdam, very close to where Iris's atelier is. And we managed to get the first material sample working, with about 3 hours before the deadline, when it was either this garment's going to go or not go.
Yeah.
So it was really down to the wire, but there were
Down to the wire. Oh my
hundreds,
goodness.
hundreds and hundreds and hundreds of prototypes.
Wow.
And yeah, it was definitely the most challenging and intense project I've ever conducted.
But you
Um,
pulled it off. You pulled it off, and that's the important thing.
yeah,
And
well, I think the really interesting thing here was that getting the material working was one thing. Um, that was an enormous challenge. And then we sat there and we made the first material sample. I think I might even have got an image of it somewhere. Let me just have a little. I've got a photo of me with the first material sample, but no, I haven't got it in this presentation. But we made this first living sample, and then as it came out, we then suddenly said, "How on earth are we going to keep this alive?"
yeah.
So suddenly, we had to work out how we were going to keep this dress alive in the real world. And it happened to be going through the heat waves in Amsterdam. So Iris's atelier didn't have air conditioning. It hit 38 degrees at one point. And we were trying to, these algae are happiest around 20 degrees. And so we went through this really fascinating transition of her whole atelier and everyone in there had to start completely changing the language and how they related to a material, because they're used to being able to, sew a material through a sewing machine, leave it in the sunshine, put it around the atelier. If they mess up a piece, then they can make another piece. And so we had to start, really educating our whole atelier in this completely different act of care. And actually, the worst possible thing happened where 3 days before the final show in Paris, something happened, something happened. But anyway, the
Oh,
dress.
no.
And so 3 days before the show, we had to completely remake the entire dress.
No. Oh,
Um,
goodness.
and it ended up with me, yes, I had to travel, with luminescent algae in, like these artificial kind of transport growing boxes on overnight buses from Amsterdam to Paris. And it was the
Yes.
most, I think there was that act of care was the real learning that everyone got about it. And
Mm.
the whole atelier developed a completely different language
Yeah.
about this garment and about the materials. And that was the real transformation.
And that must have been incredible because obviously, from an aesthetic point of view, her work does look very organic. But this would have clearly been the first time that they were really working with living materials, materials that need to be. I think another analogy you used was almost like a pet. And I saw the marvelous contraption. I'm not sure if you've got a picture of it you can pull up, but it
Mm.
looks like something out of Prometheus or like of Alien. It looks like something Ripley would have stepped out of and has got the dress
Yeah,
in
let me
it.
see if I can find
The
it. Hang on.
the uh the cooling chamber. Have you got a picture for the audience?
Yeah, let me just grab it. It's right here.
So I mean, I'm thinking, when you designed this material, when you created the material, it was not just the material itself, it was all of the processes around the development of the material, the care of the material, actually, even the transportation. You had to think through, didn't you, how you were going to safely get these organisms, this material, to the Italia without the algae dying off.
Yeah, exactly. And I what was remarkable was that I'd actually built up such a language of care that people cared so much about the dress that to come back from Paris, they rented a refrigerated lorry. Um, because they were so worried about the algae getting too hot or not being happy or not illuminating that they
Yeah.
rented an entire refrigerated lorry to make sure that in the heat wave it didn't get too hot while it was on the road.
Yeah.
In reality,
And
that was
you had the worst conditions, didn't you? I mean, it was an extreme heat wave. So, you were facing much tougher circumstances than had this been a show in the middle of the winter.
yeah, exactly. Yeah, there we go. There's the
It's
chamber that we
incredible.
yeah, that
Well,
that chamber was, we had to build it in about 24 hours because I was told that after the fashion show that, the whole world would want to come and see the garment, and so it had
they
to be
would.
on. So,
And I'm
yeah.
wondering, I mean, the film that I think of when I think of this, as well as Alien, it would have to be Avatar, because this is basically Avatar come to life. I used to use Avatar as an example of how fashion and design would evolve back in the noughties. And at that point, it wasn't clear how long the timeline would be for this to actually come online. But you have created something that could be, it's the stuff of science fiction, but it's now science fact that you have actually made this. Have you found that you have had, I mean, obviously, I know the fashion world has been very excited, but have you had the movie world rallying around, getting in touch with you? Have you had any people reach out and say, we think what you're doing is incredible, and invitations to work with directors?
Uh, Nothing in film, actually. A lot of people working more in kind of experiential, so kind of musicians and artists who love the fact that it's kind of live and interactive. Um,
Mm.
but I think what the most interesting one was, um, and maybe this is because of how we presented it, and maybe this is because I've got a background as in engineering and actual product development. Um, but one of the most interesting requests I had was from Speedo. Um, and Speedo reaching out to me and saying, "We love your material. How many kilometers of this fabric can we order?" And
7 kilometers.
yeah,
That's great.
and fascinating that you can create something that is that, where people are so inspired that they're asking about how can this be scaled up. And obviously they've missed the entire point of the project, because the whole point of the project is that we shouldn't be growing material, we shouldn't be talking about materials in terms of kilometers. We should be talking
Mm,
about them being grown in bioregional ways, and in this
mm,
distributed kind of like biology would do it itself.
yeah. I mean, I'm thinking in terms of throughout the earlier BioFutures conversations, and obviously within this general field, we think a lot about the process of production and that uh, the dichotomy of scale, versus the sustainability and where the sweet spot is. Because obviously you've got to have enough units, you've got to be able to sell enough that you've actually got a commercially viable business, but equally you don't want to just replicate the old way of doing things because, as you said, if you don't actually look at the whole of the system, then you're in danger of turning something that is intended to be sustainable into just another way of working that is going to wreak havoc on planet and people. But one of the things that I think really was a major theme, certainly of the first and second series of BioFutures, was the idea of localized production. So, for example, we had with Full Grown the idea, obviously they grow furniture, they have a furniture orchard and they're growing the chairs among other various different objects. And the idea that you can actually have community furniture orchards. And of course, the orchard doesn't just produce the chairs and the various other things that you might use in your home, or your office, but also it is a living ecosystem. You can, if you're growing fruit trees, then it's also an agricultural production system. So it's this highly complex production unit that is fully integrated with the natural world. And then actually, just before you, we had the wonderful Sam Moreau, also in France, and she was talking about the fact that the process of developing their materials, Planet of the Grapes, she actually goes down to the vineyard. She's involved in the harvesting. She's involved in the early kind of the process of actually winemaking, and then extracting the materials that she and her team then turn into the materials that are used in accessories, used in garments. And now actually, relating to cars, they've also done a collaboration to use their fabric actually for car seating. So, and it looks great. I mean, it's a brilliant alternative to leather. So this idea of the production unit, it's going back to, in the industrialization, everything became centralized. And now it's going back to cottage industry. It's going back to micro, isn't it? It's going back to distributed, not centralized production as a model. Is that how you see your area of materiality evolving, or do you see a hybrid or something else?
Yeah, I actually, the shoe project that I worked on, um, one of the concepts we came up with when we were doing that shoe project was we designed an entire shoe factory that could fit inside a shipping container. Because actually, with technology now, production equipment can be, miniaturized and really, made, you don't need a huge factory to do something.
Mm.
And the idea of that was twofold. One was that you can have a factory, distributed all around, so you could facilitate local production. The reason it was in a shipping container was because we wanted to actually put it on a ship because of all of the kind of the duties and the taxes and so on. If you could
I love
manufacture in international waters
it.
while
Yeah.
picking up your raw materials in China, they're then manufactured during the journey in international waters. So it was a wonderful kind of concept. But that miniaturization of production is, for me, is really where the future is. And I really enjoy the field of bioregional design, particularly the work of places like Atelier Luma. I think that work is really, really special. And that's actually what I'm trying to build into. I've now started working in the food industry. And I have a project called Yana. It stands for You Are Not an Astronaut. And it's a mission to try and get athletes eating real food again. And with that, we're producing real food, sports nutrition, but it's in the south of France. We work with a family kind of producer in Provence. The majority of the ingredients come from organic cooperatives around the area. The salt comes from Camargue, which is not too far away. The olive oil comes from the Pyrenees, which again is as close as we can get. And so that principle of bioregional design, I think, is really powerful. And the reason I'm working in the food industry now is that while the work I do in conceptual living materials is very much in the far future, we also have a very pressing and urgent climate crisis. And for me, food is when it comes to bioregional production, when it comes to working with living materials through fermentation or through any of the processes that are very normal in the food industry is far in advance of anything else. When it comes to biotechnology, the food industry is light years ahead of any other industry that's trying to explore biomaterials. And so for me, I'm playing in the food industry both to learn, but also because it's the only industry, I think, where you can really argue at a fundamental level that this is necessary. Because I think the crisis that many creatives have, that I had, was that we're trained in how to make stuff, and the one thing the world doesn't need more of is more stuff. And so that's why I'm now putting a lot of my effort into the food industry as a near-term future, alongside the far more the more reaching stuff I'm with living materials in other industries.
And I have read the reviews. I have read that it's rather yummy, the food that you're producing, which is really important. So it's ticking multiple boxes. It's not just helping to address environmental issues. It's not just helping local economies, but it tastes fantastic. So that's really important.
Yeah, but it's very interesting because I used to be an athlete. I used to be an endurance athlete, and what I realized was that the psychology and the mentality that athletes have when they approach sport is really an embodiment of scientific reductionism. Athletes will refer to eating as fueling. They
Yes.
will talk about their body like it is a machine. Energy in equals energy out, and the human body has been dramatically simplified to the point now where sports science is focused on purely consume X grams of sugar to have this output. And we've completely lost perspective in the sports industry that the human body is this remarkable, very complex living organism that has a microbiome, that has that we have
Mm,
psychological influences
mm,
on ourselves. And so for me, actually, the sports industry is a place where we can really try and, this reductionism, scientific reductionism, is so prevalent and so ingrained. And
mm,
it's the space where we can go and make the biggest transition as quickly as possible.
mm,
Because sports science research now shows that when you start treating your body like a living organism, when you start to say, oh, I need to support my microbiome because I've got a good microbiome, I can actually more effectively digest what I'm eating, which can give me more energy. And
mm,
so when athletes start to think more ecologically, when athletes start to embrace this systems thinking,
mm,
that's the key to being a really high performance athlete. And so what I love is that all of this, really deep thinking around life, ecological thinking, and so on, sport brings this opportunity where we can take it so quickly into people's day-to-day lives and try and change people's perceptions of nature, but also themselves as
mm,
a living
mm.
organism.
So you're looking at the things for the outside of the body, you're looking at the inside. It strikes me there is a connection. Some of the earlier conversations that we had in this series, because the whole of series 2 is dedicated to biomaterials for the body, for health, and for healing. And one of the conversations that we were sort of, I guess you could say, the most futuristic was with Susanna Radneva, and we were talking about what possible clothes might look like, and we were talking about them as sensing, in the capacity of sensing, being able to sense what's going on with your body. And I'm thinking with yours, with your work, I'm picturing this garment that can detect if you've got a fever, whereas some other indicator that your immune system is struggling. And then at the other end of it, something to consume that in a very holistic way is going to help address your health, maybe enhance your immune system through a microbiotic process of some kind. And so it really is whole systems thinking. And it also, I think in your work, in your career, you show something I've seen in that of a lot of other people. So if you look at Rachel Armstrong, she was a doctor. She was a medical doctor before she became the living architect working with living building materials. And that really shows in everything she does. If you read her papers, if you read from her thesis to her books to everything, she thinks like a doctor. She thinks about a building like a doctor. And in your work, I'm seeing this synergy because throughout your career, these early origins are really showing you are thinking about things at a systems level. And I think you're very much emblematic of many people in this domain are polymaths. They're working simultaneously. They're not just an A or a B. They've got potentially a number of different job titles, and that's you. But fundamentally, what it comes down to is looking at the problem in detail. And rather than just saying, I'm going to try and fix this little bit of it over here, actually going back and looking at the whole picture. And for you, even, I mean, I love that story about the shipping container because in that you were thinking about the realities of how do we run the business? How do we deal with the administration, the taxation, and all these things, which, as we know, can be a real challenge when you're trying to develop startups.
Yeah, and I think for me at the core, a lot of people write. I get a lot of kind of people are writing to me and saying, "How can I be a bio designer? How can I become one?" And as far as I'm aware, there isn't a single job posting on LinkedIn with the job
No,
title
I don't
designer.
know. There is. Yeah.
Um, I think that bio design is a field where it has to be interdisciplinary because what you're doing is you're applying a methodology and a way of thinking. And for me, biodesign is about, first of all, different materiality, which is working with nature, but second of all, prioritizing creativity. And for me, creativity is key because you can work with uh, the emotional. You're not only working with the irrational, with the material, with the fundamental. You're also working with the emotional, which is how us humans connect with and behave with objects and materials. Um, and so that for me, that's what biodesign is. But you can apply it to any different field. And so being interdisciplinary is essential, but also that's where the exciting stuff happens because it's when you start to smash together different spaces that you can create new environments to work in.
Absolutely. Absolutely.
Going back to your comment around creating living garments that can tell us when we're sick, I think this is something that again has I think come from all of my work kind of combined together, but we've really forgotten that we are living things. The fact that we even think that we might need to create a device to tell us that we're feeling something. And actually, this comes from, I used to, my first sport was rowing. I rowed at a high level. And when you're rowing, you can't have a computer, you can't have anything measuring you because you are in the boat, you're thinking about the rhythm, the other people you're rowing with. And so you develop this really innate sense and feeling for your body's capacity, the rhythm of the boat, everything going on around you. And when I look at, sports now, cycling, triathlon, trail running, where people have got devices to measure every single part of their performance, um, we get people who, when we're giving them the sports nutrition from Yana, they ask for, exactly, well, how many grams should I be consuming per hour? How often should I be taking it? And we've really started to lose this ability to listen to our body and to listen to our fundamental needs. And I think that it's a skill that we're going to have to really try and keep because we don't need technology and devices and objects to tell us what we're feeling. We are living things, and our gut feeling is the most powerful analysis of thousands and thousands of inputs. And if we try and simplify what we are as a living organism into, a single output or a recommendation or whatever it might be, we're losing so much resolution that the complexity of life and living things give us. And so for me, I'm so determined to try and move back to this more ecological way of thinking, whether that be in sport or through materials and other applications. So yeah, I just thought I'd kind of catch that.
Yeah. And actually, that Professor Julian Vincent, it was about 20 years ago. We were having a conversation. It was I met him very early on before my PhD, so we're going back before 2010 even. And I remember one of the earliest conversations I had with him was about just this subject. He talked about the fact that many people have lost the ability to read the signals that their body is telling them. So the fact that if you do have a fever or you do have something else, it's your body actually communicating to you, well, this is going on, basically. And I guess what we've lost is the granularity, because we went into that industrialized era of medicine, wherein if you had a pain, if you felt a bit unwell, oh, you take a painkiller. Well, when you take the painkiller, obviously the signals that could tell you about what is wrong with you are suppressed. So that could actually be a problem, because you're not, as you said, you're not listening to your body. And I think there's a synergy there between what you were saying about the Polynesian culture, because they, as would all of the indigenous peoples and indeed all of our ancestors, would need to be able to go out into the environment with no mobile, no GPS, no nothing, and navigate the environment, sometimes across vast distances in difficult conditions, in ice ages, and have that literacy of what is going on, in that space, and to defend themselves and to keep themselves healthy with really very little materially, because they were carrying whatever they had around with them on their journey.
Yeah, and I think for me uh, one of the most visible examples of this would actually be the Iris van Herpen project. So we had a couple of months to develop an entirely new biotechnological process, and the process we ended up developing, it's about a 50-step process. It's incredibly complex to try and create this this living material that can be in the real world. If we'd followed a traditional robust scientific process of testing variants and then developing each of those variants, I think it would probably have taken us 5 to 10 years to develop that technology. But instead, the approach that we used was that I've spent 18 months working very, very closely with this bioluminescent algae, constantly making prototypes, testing, developing, refining. And I developed this kind of feeling that I had a relationship with the algae. The algae have got a circadian rhythm. So if you take the algae on a plane, they will be jet lagged. It's kind of wonderful. It makes them feel very alive. But also, the amount of light they emit is very much proportional to their health and their well-being. And so over these 18 months, I developed this very intuitive understanding of what worked for them and what didn't work for them. And the only reason the Iris van Herpen project was possible was because I was able to, let's say we were mixing up a gel that the algae were going to be in, or we were testing a different coating. I was able to have that very intuitive feeling of, this is a bit thick, or it's not quite thick enough, or we're curing it in that, in that chemical. It's not going to like that. If we tried to do that in a robust scientific way, it would have taken years. But
Mm,
because we were able to use this kind of gut feel and intuition, it meant we could
mm,
develop something so much quicker. And I think
yeah,
that's, it's a nice full circle way. It connects all the projects I've been working on.
absolutely. And there's just two things as we draw near the end. First of all, I just want to say thank you for the fact that I saw a post on LinkedIn the other day, and you made the point that your female co-founder in your food company should be CC'd on. She should be on every email that is sent to you in respect to the strategic decisions of that company. She is your partner, and I've noticed generally in your work, you work and you've had a number of collaborators that are women, many women. I mean, I look through and there's a number that have been in this series. There's Carol Collette, there's Nancy Dinas. We've got a little heads up for International Women's Day. We've got three fantastic ladies next Sunday, one of which is Thora, who again I saw was one of your collaborators. You have worked with many great women and you are a real champion of that. And that's pretty unusual, because there are not that many individuals that I think are so proactive in that space. So I wanted to thank you for that, just on behalf of we women in STEM that notice there's not enough of that going on. And just to go on to, I always end these with two themes. So number one, that we've got a wish list It's inspired rather by Boyle's wish list, in which he wrote down all of the things that he wanted for the future. He wanted various different innovations and discoveries. So first of all, Chris, I would like to know if you could have just one wish, any wish that you could add to that list, what would it be?
I going back to your avatar reference, but I would like for us to feel like we can reconnect with the ecosystem. And the visualization in my head is when they have that. I don't know whether it's a tail or whatever it is, and then they connect
Yes,
in
kind of tail thing that plugs into the tree.
connect into the mother tree.
Yeah,
That for me would be my wish for the future, where we
love
can
that.
read and feel and connect to the ecosystem that we're part of.
Brilliant. Loving that. And secondly, this is World Futures Day. That is why this trio of sessions is today. The year is 2050. What, in your mind, does it look like with respect to the domains of activity you are working on?
Yeah, I think it's clear for me that we won't be able to make a change as a society to maintain our planet and environment and society as we know it. Um, I think that is what most kind of focus at the moment is about, preserving what we're part of. I'm now very strongly of the belief that we need to think about how we adapt and how we change. I think that dramatic change in our environment and everything that goes with that is inevitable. Um, I believe that nature will be just fine. Nature may change; it may look slightly different, but nature will will be absolutely fine without us. And I think for me, the question we need to ask ourselves is about, do we want to be part of nature in the future? And so I think for me, that is, in 2050, I think that's the kind of the fundamental question I will be wrestling with, which is about, what role do we as humans choose to play in nature in whatever shape and form it's ended up in the future.
Brilliant. Well, it's been such a pleasure, Chris. I could speak with you for hours because you are fascinating. I love your way of thinking. I love the projects you're working on. And I've got no doubt that you've got some very exciting things up your sleeve with a
No,
mind like yours. So thank you for joining us today. And I hope to catch up with you again soon.
thanks, Melissa.
Take care. Bye bye.